Hey guys, it's Bill from Linden, Tennessee. If you're looking closely, not too closely, the first thing you'll notice is there's no battery in there anymore. Well, that's not exactly true. The other battery is not in there anymore. The Leaf battery is no longer in there. I've got a Chevy Volt battery in there just for temporary. The Leaf battery is over there. Why? Because during yesterday's video I said that every time I get close to finishing a project I like to sort of step back, just calm down a little bit, think about what I'm doing. And I find that when I do that, answers that I didn't know I had a question to are answered. Questions that I didn't know I needed an answer for. Right? You see what I'm trying to say. This morning I was sitting there eating my cereal, as one does, and it occurred to me that I may have wired the throttle wrong. So there's 4 different kinds of throttle that you can have. They basically boil down to a Hall effect style sensor. That's what's in any car with a drive-by-wire throttle. And then you've got potentiometers. That's kind of what you think of if you think of a little knob that has sort of like a little clicky noise or whatever. Think of like them little cars, the little race cars on the track when you were a kid and you had the little throttle control with the little pistol grip. Yeah, that's a rheostat. Anyway, I had the wrong wires coming out of the controller to go to it. So I had the wires for the rheostat, but I have a Hall effect sensor. And that makes a big difference because there's no wiper per se in a Hall effect sensor. In a rheostat, basically you have a coil of wire that goes around in a circle, and then you put voltage in one end of that coil, and then you have a little wiper that moves along that coil of wire, and as it gets further away from the source of the voltage drop increases. So as you push the throttle further, the voltage goes down. They also have them the other way around too. It goes the other way too. But yeah, so but anyway, I've got the Hall effect style. Oops, excuse me. I've got the Hall effect style. So this has a wiperless system, and basically it's just got another coil of wire, but it's got a magnet in the middle, and as that magnet moves past that coil of wire, a voltage is induced, and that's picked up by the controller. Anyway, long story short, the only way to fix that problem was to get to the wire connections coming out of the controller, and I couldn't do it from the bottom, so I had to do it from the top, and the only way to do that is to get the battery out. The cool thing is that the battery is not terribly difficult to remove. There's some big cables that you got to remove. You got to remove the reservoir. It'd be a real nightmare if I had water, if I had coolant going through this thing. That would have kind of sucked, but I don't. So because you do have to remove the coolant reservoir. You have to remove that little front part with the contactor on it and the water pump. You got to remove all that stuff. So anyway, so I did that, moved it, swapped the wires over, and went on to finishing wiring up my my instrument panel here. So you can see I have a whole bunch of unlabeled switches. I need a solution for how to label those switches nicely. I mean, I could put individual labels on it, like get one of those little label makers, but I'd like kind of something nicer, sort of an etched something or other on plastic or even metal would be cooler. But anyway, I got all them on there. So as we're looking at this side of the switches, the lower left is the forward and reverse switch. The upper left is eventually going to be the up-down control for the 3-point hitch. The upper right is the winch in and out, and the lower right is the fog lights, or the front 12 volt. On the other side, the lower left is the power takeoff arm. In the middle there is a little rheostat for the power takeoff ramp up speed controller. Upper left is the power takeoff full power. Lower right is the key switch on, sort of the accessories, and then the upper right is the controller, motor controller on. Now I don't really need both of those switches. I could do with just one, but I have two. That way if I want to just have the key switch on, say I want to just use the power takeoff to run lights or an inverter or whatever in a stationary way, then I don't need to have the controller on, so I don't need the water pump on and all that other stuff. So I can just switch the controller off, but still have the 12-volt system fired up with the DC-DC, keeping the 12-volt battery charged, all that stuff. And then when it comes time to go, then I can just flip that upper right switch forward, turn my controller on, and come over here, select a direction, and go. And yeah, so that's how all that is. And in this in that little circle right there is going to be a little push button switch, and that'll control the modes of the, they call it a spyglass. Curtis Controllers calls that a spyglass, but it's just got like RPM and motor temperature and voltage and amp draw and all that stuff. And of course there's a 12-volt battery. Now that little wire sticking out of there, that's a jumper wire for this display. So I'll get an on-off push button, a latching on-off push button, and then that'll just turn that display off just to kind of conserve battery consumption. Now this thing doesn't use hardly any, but it does use some. So if I've got this tractor parked up for the long winter, then I can turn that switch off and just conserve the battery. And that's how all that looks. Last time showed you how this all got wired up. There's a, yeah, gotta put that up there, didn't tie that back. This little switch hanging down here is, it took a little while to figure out why that's sitting there, and I'll get to that here in a minute. But yeah, so that's how that's all wired. Dashboards always end up being a mess, just a disaster with wires going everywhere. Now I aspirationally wanted to have a single wire harness that I can just take out whenever I go to strip this thing down and strip the paint and paint it new. I wanted to be able to just take this wiring harness out in one piece and be done with it. And for the most part I can do that. However, what I'll end up having to do is I'll have to disconnect these connectors here, remove them, and then all of those wires will just kind of go off with the dash assembly. And yeah, I mean, it's not a big deal. So, but that's how that's going to work. And then all the wires from the connectors back, that'll all come out as one unit, I think, but I don't know. But like I said, I have this temporary battery in here. Let's show you why. Can I get a drum roll, please? Key switch on. Voltage is coming up. I've got a reading on my display there telling me that my DC-DC converter works, and I've got more than 13 volts on my 12-volt display showing me that that works. Then I'll come over here to this switch, flip it on. Hear a click. The little display says code 29. Stand by. Yeah, so where was I? Yeah, code 29. So what code 29 means is there's a motor temperature sensor problem, and I will talk about that in a minute. But anyway, we got it on. Put it in forward. Push the gas. And there we go. Now, something very unimpressive, this is full speed. I've got the throttle pedal pushed all the way down, and obviously it's not going very fast. So that's not good. And now my sensor's beeping at me because the voltage in that little volt battery is too low, so I'm going to shut this thing down. Anyway, you see I got it running, and so we've got a few issues. It took me a while to figure out how to get it going because this little button I was talking to you, that needs to be a normally open button, and like I said, that's used for scrolling through the display. Well, I had a normally closed push button on there, so it wasn't allowing this thing to go, and that took about a half hour to figure out. And this is the connector for the wires that come from the motor sensors, so temperature sensor, and there's a couple encoders in there that tell the controller where the motor is, what its position is, and its RPM. I think the wires in that connector are swapped, are goofed up, and I'm not exactly sure where they are. I've sent a called out. I phoned a friend, so we'll try and get that sorted out. But that's also why I think the motor's not spinning as fast as it's supposed to. What I think's probably happened is the temperature wire is going to the encoder, and one of the encoders is going to the somewhere else, and it's just wrong. So the fact that it turns at all is kind of a miracle. So anyway, yes, so we have success. We've got some little hiccups to nail down, but nothing too terrible at all. Pretty thrilled. My heart was pounding the first time I turned this thing on, and but anyway, yeah. So it goes, and feels pretty good. So now I think the next thing I'm probably going to do, the reason I didn't put that battery back in here is that now that I know that it goes, I'll get these motor parameters fixed, and I think I'm just going to tear this thing apart so I can clean it and paint it, and that's daunting. There's a lot of pieces in here. But anyway, success, and I'm thrilled. So thanks for watching, thanks for sticking with me, and we'll see you next time.